Question number 11. Integral of 5x upon x plus 1 into x square minus 4. Now this can be reduced into linear form like this. So 5x upon x plus 1 into x minus 2 into x plus 2. So now in the denominator you have product of three linear factors. So we'll use partial fraction method. So this is equals to one constant upon one linear factor plus another constant upon linear factor plus third constant upon third linear factor, the whole dx. Now as you know, we get a, b and c. How do we find? Just comparing numerators. What is numerator here? 5x. What is numerator here? You need to do the cross multiplication, I mean LCM. So a into product of these two, which is x minus 2 into x plus 2, plus b into product of these two, that is x plus 1 into x plus 2, plus c into product of these two factors, x plus 1 into x minus 2. Okay, so we have compared numerators 5x and your LCM. Now we find a, b and c. You know what's the procedure. Take x equals to minus 1, so this becomes 0, and place in the above expression. So left hand side is minus 5. Here a into minus 1 minus 2 minus 3. Here 1. Because of minus 1, this is 0 here, this is also 0. So you have value of a, which is how much? Minus minus will get cancelled, 5 by 3. Okay. Next we take x equals to 2. If x is 2 here, left hand side is 10. What about right hand side? Here 2 minus 2, this is 0. Here b into, I'm putting 2, so 3, and this is 4. If I put this here 2, so this is also 0. So you have b here. What is b from this? This is 10 by 12, so which is just 5 by 6. This is 12, this is 10, so 5 by 6. If x is next, in such a way that this becomes 0, that is minus 2. So left hand side is minus 10. 5 into minus 2, minus 10. A into, if you put minus 2 here, this is 0. Minus 2 here, this is also 0. C into minus 2 plus 1, which is minus 1. Minus 2 minus 2, which is minus 4. Minus 2 plus 1 minus 1, minus 2 minus 4. So we'll get the C from this. So this is nothing but plus, and because of this here it is minus 5 by 2. Minus minus will be plus, so plus 4, and this is minus 10, so minus 5 by 2. Okay, now we place these values in the above expression. So if I continue with the same integral, a is 5 by 3 upon x plus 1, b is 5 by 6 upon x minus 2, and c is minus 5 by 2 upon x plus 2. So this is what we call the partial fraction method. Now we just integrate in a line, remember. So this is equals to 5 by 3 being constant, it will come out. This is a linear function. So log of mod of x plus 1. 5 by 6 come out here. This is log of mod of x minus 2. Minus 5 by 2 will come out. This is log of mod of x plus 2 plus c. This is the required integral. So the important part is calculation of ABC here. The question number 10 you might have finished. It is just the copy of this So question number 10 is same as question number this one 11 here. So if you are not done, you can do the same way. There you have in the denominator x square minus 1. So you factorize this as x minus 1 and x plus 1. Okay, now in this question number 12, you can see that the numerator expression has more power than the denominator expression. So directly partial fraction method cannot be used here. This is like question number 6. You just go back to 6th number, you will realize. So what I need to do? I need to reduce the power of this. So first the simplification, remember. Now here one way is you can do actual division. You see division of one polynomial by the other polynomial. X cube plus x plus 1 is divided by x square minus 1. Here I have x square, I need x cube, so I'll multiply this by x. So this become x cube minus x. I'll change the sign. So here minus plus, this will get cancelled. This is 2x minus 1. Now this power is less than this, so now further division you cannot do it. So here this x cube plus x plus 1 is, you know, these into this actual division concept plus remainder, that is 2x minus 1. Now do individual division. So the above integral reduced to x into x square minus 1 plus 2x minus 1 upon x square minus 1. This upon this, it is just x plus 2x minus 1 upon x square minus 1. So now here this term can be integrated very easily. So this is just integral of 1 here plus 2x minus 1 upon, what are the factors of this? X minus 1 and x plus 1. Now for this you can use the partial fraction method. I'll call this as 1 and I'll use partial fraction method for this. So 2x minus 1 upon x minus 1 upon x plus 1. So you have a upon 1 factor x minus 1 plus b upon another factor which is x plus 1. Now compare the numerators. What is numerator here? 2x minus 1. What is numerator here? Do the cross multiplication. Plus b into x minus 1. Cross multiplication. Now first I'll take x equals to 1. If I put 1 here, this is just 1, 2 minus 1. Here a into 2 plus 0. So you have the value of a, which is half. If here x is minus 1, minus 2 minus 1, which is minus 3. This is 0. Here minus 2. So you have b. What is b? Which is here 3 by 2. Minus minus will get cancelled. This is 3 by 2. So therefore here 1 upon 2 upon x minus 1 plus 3 by 2 upon x plus 1. This is the reduced integral. So by 1, if I write by 1, we have here integral of 1 plus half upon x minus 1 plus 3 by 2 upon x plus 1. This is the final simplified form, remember. What is integral of x? X square by 2. Half being constant outside. This is log of mod of x minus 1. 3 by 2 being constant outside. Log of mod of x plus 1 plus c. This is the simplified answer. If I just go back to beginning of this question, the important part is this, remember. This is the important part here. you cannot use directly in this question partial fraction method, because degree of this one should be less than this, then partial fraction method can be used, otherwise no. So by doing actual division, what I did, I have reduced this one in such a way that you have now linear upon quadratic. So here I have followed the partial fraction method, remember. Now if you don't want to do division here, you can do alternatively like this also. See, I'm doing or just reduction of this numerator expression. If you don't want to divide x cube plus x plus 1 upon x square minus 1. What we do in such questions, we set this expression over here in the numerator, and I want to reduce the power also, so I'll keep x cube as it is. I'll add plus x and subtract x, so I'll write here minus x. Why I wrote this? Because from these two, if I take x common, you will get x square minus 1 inside the bracket. Now if I subtracting x, I need to add plus x. X is already there, so this become 2x plus 1, the whole upon x square minus 1. What I did, I have subtracted x and added x. X was already there, so this become 2x. Why I did like this? Now you take x common from this, so you'll get the x square minus 1 plus 2x plus 1 upon x square minus 1. Do individual division now. So x square will get cancelled. This is just x plus 2x plus 1 upon x square minus 1. So you can see that this is just same as this, which I did by division. If you feel that this division procedure is easy, you can do this way. Otherwise, you can just rearrange like this. Choice is yours. Question number 13. 2 upon linear factor into quadratic factor. So we'll go for partial fraction method directly. For linear, one constant, a upon 1 minus x. For this quadratic, you need to set linear, which is bx plus c. A I already used, so I wrote bx plus c. You know that this is a general form. Upon 1 plus x squared the whole dx. Constant upon linear, and this quadratic, which I have set here linear expression. Now what we do, we compare the numerators, and then we get a, b and c. Okay, what is numerator here? 2. What about this cross multiplication? A into 1 plus x square plus bx plus c into 1 minus x. Cross multiplication, a into this, bx plus c into this, and then this denominator and this denominator will goes away, so you are left with 2 numerators. Your numerator is 2, your numerator is, after cross multiplication we have this. Now we need to find a, b and c, so we need to choose 3 values of x. There are 3 unknowns, a, b and c. First, take x in such a way that this becomes 0, so x is 1 here. So this is 2, a into 1 plus 1, that is 2. If I put 1 here, this is 0, so you have a equals to 1. Next, you know there is no x, for this becomes 0, but you need to take 3 values. So next I'll take 0. You can take anything, you can take 2, 3, 4, 5, but I have chosen 0 here, so calculation becomes easier. If I take 0 here, this is 2, here a into 0 plus 1, which is a. I'm putting 0 here, so b into 0, 0, so this is c, and here I'm also putting 0, so 1. So you have a plus c equals to 2. But a you know, which is 1, so here c will be again 1. Okay. You need one more x because there are 3 unknowns, so you must have chosen 3 values of x. Now I've chosen 1 because this becomes 0. There is no x for this 1 plus x square is 0. So what I did, 1 I have taken 0, the next you can take minus 1. So let's take minus 1 here. So left hand side is 2 a into, if I put minus 1 here, 1 minus 1 whole square, which is 2, plus, if I put minus 1 here, minus b plus c. Let's put minus 1 here. So this become 2 minus b plus c, and this is here, if I put minus 1, this is 2. This is minus 1 here, minus minus will be plus, so 2. Okay, you can cancel 2 throughout the expression. So here 1, this is a, here minus b plus c. This 2, and this 2 are cancelled. You have a and c, so you'll get the b from this. A is 1 minus b, c is also 1. So what's b from this? B is, I suppose, this 1 will goes away, b is also 1. So now you got a, b and c, and I'll place there. So this integral would be here. What is this integral? That is a. What is a? 1 upon 1 minus x plus b and c both are 1. So this is just x plus 1 upon 1 plus x square. Now this is 1 upon linear, so you can integrate it very easily. This is linear upon quadratic. So you need to set the derivative of this quadratic, that is 2x, you know. So I need to set 2x. So I'm rewriting like this here. I need 2x there. So multiplying and dividing by 2, you know such procedure. 2x plus 2 upon 1 plus x square. This is our earlier procedure, linear upon quadratic. What is derivative of this one? 2x. So I need 2x over here. So multiply and dividing by 2. So 2x plus 2. Now you split into 2 integrals. Right now I'm keeping this one as it is. 1 by 2. 2x upon 1 plus x squared. Plus this 2 upon this. But outside 2 and this 2 and this 2 will go away. So this is just 1 upon 1 plus x square. Now all are standard forms. So I'll just integrate. What is the integral of the first one? Log of mode of denominator expression here. Because this is linear. So log of mode of 1 minus x upon the coefficient of minus 1 x, which is minus 1, upon minus 1, which I'll write here. 1 upon 2, this is f dash, this is f. So log of mode of 1 plus x squared. No need to write mode here because 1 plus x squared is always positive. And what is this? You know this is tan inverse x plus c. This is linear function I've considered as x, but upon the coefficient of x, which is minus 1. So that's why you over here upon minus 1 means into minus 1. This is f dash upon f, log of mode of denominator expression. Modulus is not important because 1 plus x squared is always positive. And you know that this is tan inverse x. So here you can use partial fraction method, but this is partial fraction method with repeated factors. Remember, the power of numerator is less than the power of the denominator. Here power is 2 if I expand it. So one constant upon x plus 2 plus another constant upon x plus 2 the whole square. I already explained such things in theory. This is partial fraction method with repeated factor, remember. So a upon x plus 2, b upon x plus 2 the whole square, remember. Now compare the numerators. I'll just show one more step here. I'll take LCM here. LCM would be the same, remember, x plus 2 whole square every time, remember. Okay, so what we'll get here? A into x plus 2 plus just b. Now I'll compare the numerator. So what is numerator there? 3x minus 1. And what is numerator here? A into x plus 2 plus b. Right? In all earlier questions I had dropped this step. You can drop this. This is just for your information I've shown. What I did, I've compared the numerators. What's the numerator there? 3x minus 1. This one. Here LCM should be x plus 2 the whole square. So a into x plus 2 plus b. Now how many unknowns we want to get? 2 unknowns. So I need to select 2 values of x. So one I'll take from this minus 2. If I take minus 2 here, minus 6 minus 1, this is minus 7. This is 0. So you have b. One more you need to take. Now your minus 2 already taken. So you can take 0. So let me take 0 here. So if I take 0, this is minus 1. You have put 0 here, this is 2 plus b. Now b you know, so this is minus 1, 2a, minus 7. So therefore 6 equals to 2a. So a is 3. Minus 7 I'll take on the other side, plus 7 minus 1, 6. So a is 3. Therefore a upon a means 3. 3 upon x plus 2. What is b? Which is minus 7 upon x plus 2 the whole square. So now you can integrate it. How do we integrate this? This is linear function, 3 outside. This is log of mod of x plus 2. Minus 7, this is linear. This is like x raised to minus 2, remember. What's the integral of this? X plus 2 minus 2 plus 1 upon the same number minus 2 plus 1 plus c. This is like x raised to minus 2, remember. So I've used that x raised to n formula, minus 2 plus 1. So 3 into log of mod of x plus 2 as it is. This is minus 1 and here this become plus 7 and this I'll take over denominator. So this is x plus 2 plus c. So here you can factorize like this, x square minus 1 into x square plus 1. Now everywhere you have x square, so you can consider like x square equals to y. This is not substitution, this is like a new variable. So what we'll get here? Y minus 1 into y plus 1. This is just for partial fraction method. We'll not convert the integral into dy, remember. Now how we'll do this? One constant upon y minus 1 plus another constant upon y plus 1. Compare the numerators. Your numerator is 1. What's the numerator here? A into y plus 1 plus b into y minus 1. A into y plus 1, b into y minus 1. Now we choose the value of y. Here 1 we take y equals to 1. So a into 2 and this is 0. So a is half. Next we take y equals to minus 1. So this becomes 0. So here 1, this becomes 0 and b into minus 2. So b will be, I'm putting minus 1 here, remember. So b will be minus 1 by 2. So here if I now resubstitute this, so x square minus 1 into x square plus 1, that is equals to, what is a? Half upon y. Y was x square minus 1. What is b? Minus half upon x square plus 1. Right? So just considered x square equals to y. This is not substitution, remember. This is just consideration. So our partial fraction method become little bit easier. Okay. So finally, now this integral is here 1 by 2 upon x square minus 1 minus 1 by 2 upon Here, sorry, this is x square plus 1, so x square plus 1. Now we can integrate because both are standard forms. 1 upon 2 outside. This is like x square minus a square. If you remember, 1 upon 2a, a is 1, log of mod of x minus 1 upon x plus 1. Minus 1 by 2 outside. This is nothing but 1 upon this, which is tan inverse x plus c. So 1 by 4 log of mod of x minus 1 upon x plus 1 minus half tan inverse x plus c. This required integral. See the example number 14 of the textbook. It is this x squared upon x square plus 1 into x square plus 4. You can see that like this question everywhere you have x square. So consider here also x square equals to y. So this will be y upon y plus 1 into y plus 4. And then just do by the partial fraction method as I did here. Now in this question you can see that directly you cannot do partial fraction method. Problem with this expression, so I'll use the substitution here. Put x raised to n plus 1 equals to t. So even you can take these also, remember, or just x raised to n equals to t. Final answer remains same. But this is constant, so I've taken with that. Okay. Now differentiation after substitution, you know, n into n minus 1, derivative of 1 is 0, dt by dx will go that side. So you have this. Now you want just dx only. So dx equals to here 1 upon n into x raised to n minus 1 dt. Just take this down there. Therefore, now if I just place this value, if I place the value of dx, this constant will come out, 1 upon n will be out. This n minus 1 power and this 1 power gives you x raised to n. And this is t dt. I just repeat this. What I did, I placed the value of dx. So that upon n being constant outside, this will be in the denominator. 1x is already there if I place the value. So n minus 1 and 1, that is x raised to n. This is t, remember. Now you cannot keep in form of x. So I need to reduce in t. How do I reduce? Put the value of x raised to n, which is t minus 1 into t dt. Now you can see that this is a product of two linear factors. Your factors are so simple, so I can just do directly by partial fraction method. What I'll do, I can write here t minus 1 upon t. I need to cancel t here, so I'll put minus sign. Let's see what you'll get. Just check. If I do the cross multiplication here, t minus t plus 1. So you can see that you are getting same 1. If you do partial fraction method, you will see that a will be 1 and b will be minus 1. This I did directly, remember. Okay, now what is integral of the first term? Log of mod of t minus 1, linear factor, minus log of mod of t plus c. Put the value of t, and I'll use simultaneously property of the log function. Log x minus log y is log of x minus y. T minus 1 upon t. But what is t? That is x raised to n plus 1 minus 1 upon x raised to n plus 1 plus c. What I did, I've just placed the value of t, remember, and I've used the property. T is x raised to n plus 1. So finally, 1 upon n log of mod of x raised to n upon x raised to n plus 1 plus c. This is the final integral. Same way, you can just do the question number, further question number 20th. It's just a copy of this. See the question number 20th, which is integral of 1 upon x into x raised to 4 minus 1 dx. Put this equals to t. Right. And continue further like this. You will realize this is just n equals to 4 here. Minus 1 is not important. Take this equals to t and just continue. Question number 17. Here you can just notice that with dx your cos function and here your sine. So the first obvious observation is substitution. Put sin x equals to t. So cos x dx equals to dt. So this is just dt here. Cos x dx become dt. 1 minus t into 2 minus t. Now product of linear factors. So you can do by partial fraction method. A upon 1 minus t plus b upon 2 minus t. And get ab. So first here compare the numerators. What's the numerator? Here 1. Here a into 2 minus t plus b into 1 minus t. One time you take t equals to 1, get one of the value. Second time you take t equals to 2, get the value of one constant, place there an integral. And at the final answer, instead of t you put sine, remember. So this you can complete. Question number 18. X square plus 1, x square plus 2 upon plus 3 plus 4. Everywhere you have x square. This is a good question. So as you know, as we did earlier in one of the question, I'll consider x square equals to y. Remember, this is not the substitution. So you are not going to convert in dy. So you have y plus 1 into y plus 2 upon y plus 3 into y plus 4. So if you simplify, this is y square plus 3y plus 2 upon y square 4 plus 3, 7y plus 12. Now, can we use partial fraction method here directly? The answer is no. Powers are same. The power or the degree of this expression should be less than the degree of this. So it cannot be done directly by partial fraction method. So what we do in such questions, we set this denominator over there in the numerator. So I need y square, I need 7y, so I'll write plus 7y, I need plus 12, so I'll write plus 12. Now what extra I have chosen? I have 3y, but I wrote 7y, so I need to write minus 4y. I have plus 2, I wrote plus 12, so I need to write minus 10. You can just check. This is same as numerator. What I did, I have set this expression over there. This should be always done when you have same powers, remember. This is a standard question, quadratic upon quadratic. If you have any question of this type, quadratic upon quadratic, set this denominator expression over there in the numerator. You can do by division of this polynomial by this. Answer would be same. I did here directly. So I have written this expression over there. I have 3y here. I wrote plus 7, so I need to write minus 4y. Plus 2, I wrote plus 12, so minus 10. You can just check this is same as this. Now do individual division. This upon this. This is just 1. Take minus common. So 4y plus 10 upon y square plus 7y plus 12. So this is the simplified expression. And now here 1 as it is. Here 4y plus 10 as it is. This you can refactorize like this, y plus 3 and y plus 4. And here I'll use the partial fraction method. So a upon y plus 3 plus b upon y plus 4. This is now linear upon product of two linear factors. Here power is 1, here total power is 2. So you can use the partial fraction method. Compare the numerators. What is numerator in the previous step? Here just 4y plus 10. For this portion only, remember, for this much only, this one we are comparing. This and this. What is numerator here? A into y plus 4 plus b into y plus 3. 4y plus 10, a into this, b into this. Now we select value of y. If y is minus 3 here, minus 12 plus 10, that is minus 2. Here this is 1 and this is 0. So a is minus 1 by 2. Y equals to minus 3. Minus 12 plus 10, minus 2. Minus 3 plus 4, so 1, and this is 0. So a is minus 1 by 2. Next, y equals to minus 4 here. Minus 16 plus 10, so minus 6. This is 0. Here minus 4, so b here minus 1. Minus 4 plus 3, so minus 1. So what is b from this? Which is 6. Minus minus will get cancelled. So here, finally, if I just come to this, 1 minus inside the bracket, what is a? Minus 1 by 2 upon y plus 3, plus what is b, which is 6 upon y plus 4. And now I just go back to integral, that is I equals to, instead of now this expression, I'll place x square, and that is same as, let me write this here, y plus 1 into y plus 2 upon y plus 3 into y plus 4. So instead of this, now I'm just putting this, so 1 minus 1 by 2 upon what was y, that is x square, plus 3, plus 6 upon what was y, that is x square plus 4, the whole dx. Remember, I have not converted the integral into dy. Remember, I have just used this variable y for partial fraction method. This is partial fraction method. This is not the integration, remember. Now we'll do the integration. So integral of 1 is x, here plus 1 by 2. You know that this is x square plus a square, that is 1 upon a, so 1 by root 3, because this you can write root 3 the whole square. Tan inverse x by a, x by root 3, minus 6 into, now this 4 you can write 2 squared, so 1 upon a, which is 1 by 2, tan inverse x by a, x by 2 plus c. At both the places, which formula I've used? I've used this 1 upon x square plus a square, that is equals to 1 upon a tan inverse x by a. I'm just reminding you, I've used this, remember, for both of this. So here x square plus root 3, so a is root 3, so 1 upon a tan inverse x by a, minus 6, here 1 upon a means here 2, tan inverse x by a plus c. So we have this. Now here we have x square, but here there is 2x, and 2x is derivative of x square. So we are going to take substitution here. This is not consideration, remember. So now if I differentiate this, 2x dx equals to dt. So the above integral reduced to dt here. This is t plus 1 and t plus 3. And now go ahead for partial fraction method. You can do further now. So you have a upon t plus 1 plus b upon t plus 3. And continue as we did. One time you are going to take t equals to minus 1. Second time you are going to take t equals to minus 3. And your final answer should be, after the integration, place the value of t, which is x squared, and simplify. If you remember, in one of the points to remember, I told you whenever you have exponential or log, take this equals to t substitution. So I'm putting e raised to x equals to t. Differentiation, e raised to x dt by dx. Dx will go that side. Now you want just dx. So what is dx here? 1 upon e raised to x dt. But what is e raised to x? That is t. So 1 upon t dt. So we place there. So integral will be here. What is dx? That is 1 upon t here dt. And what is e raised to x? That is t. So t minus 1. Now there is a product of two linear factors, but here factors are so simple. You can just see here by trial and error you can do. I need 1 there, so I'll keep t minus 1 factor here. I'll keep t here and I'll put minus sign. This is just by trial and error. You do the cross multiplication, you will get exactly 1 here in the numerator. Or you can do by partial fraction method also. What is this? Log of mod of t minus 1 minus log of mod of t. And what is the value of t? That is e raised to x. So e raised to x minus 1 upon t, which is e raised to x plus c. Log x minus log y, which is log of x by y, but t is this, so we have this. MCQ number 23 here, question number 23. You have linear into quadratic. So one way is you can do partial fraction method, but in MCQ you can do directly like this. I'll try to set one of the factor there. So I'll write plus x squared minus x squared. What I did, just have tried to set their denominator in the numerator. So adding and subtracting x squared, 1 is already there. Do individual division, this upon this, 1 upon x. Minus, if you do this upon this, 1x will goes away, so x upon x squared plus 1. Fine. This upon this, so this will goes away, 1 upon x. X square upon x, so 1x will get cancelled, you are getting this. Now this is a standard function. So here 1 upon x dx. This is linear upon quadratic. What's the derivative of this one? 2x. So I'll set there, multiply and dividing by 2. So 2x upon 1 plus x squared the whole dx. This is log of mod of x, 1 upon 2. This is f dash, this is f. Log of mod of denominator expression, this one plus c. No need to write here modulus because 1 plus x squared is always positive, remember. So this is, I suppose, option B. Not B, sorry. This is option A.